us about knowledge engineering for planning and scheduling in the LLM era. The stage is yours.
Okay, thank you, Tim, for the introduction. So that this is a joint with Mauro Vallati, Roman Barták, Lee McCluskey, and Ron Petrick. Also, special credit goes to Mauro Vallati, who actually prepared the slides. So, I mean, here in this community, I believe that I don't have to really advocate for planning via it is cool, and what we can say that it is a pivotal aspect of what we call intelligence, because it is a reasoning about acting, like what sequence of action to do to achieve some goal, and each action has some constraints and so on, right? and Also, planning has a lot of applications. Like it might be in robotics, it might be in like game testing, like for those who saw the demo yesterday. It might be for drones and whatever. But how we actually do planning, and what is the main concept, especially with those what we call domain independent planning, because that's what knowledge engineering is about. And here the idea is that we have to represent a huge state transition system in a very compact model, right? So that this is kind of what we do from the knowledge engineering perspective. And then we have a planner that can reason with those models and find plans, right? But what is knowledge engineering? Because we might have some application that we would like to model, and we somehow need to find way how to take the concept of the real world application and model it in a symbolic model like in PDDL, for instance, right? So that also those who attended yesterday video, so that this is yesterday's demo, so that this is something what can be done also in practice, and this is where domain independent planning is very useful. And of course, now that there is what we called LLM era, because since I think 2022, when GPT was introduced, that basically everyone is trying to figure out how to use LLMs in just different means, and not only in planning. But I mean, there are a lot of these, and also. I would like to say kudos to Mauro to actually, find these papers that actually deal with how LLM can be used in some aspect of planning. So, for instance, there is a lot of work that focus on plan generation. This is not really a core aspect of this talk, but here also we have a lot of works that kind of do with a model construction. And this is not just a whole PDDL model, but for instance some parts of the model. Because for instance, if you specify a problem instance, so that you might want to use LLMs, for instance, to specify goals which are written in natural language. So that there is some promise and a lot of interest in actually how to use LLMs in planning in general. But coming back, that maybe for plan generation, LLM still might not be super great, because we might simply need models for, let's say, many aspects, not just planning. But for instance, if we have some safety related applications, then we need some sort of formal model in which we can say that the model actually behaves in a certain and desirable way, right? So that what is very critical point, especially for these type of application, that we have the ability to perform verification and validation, right? And also the explainability part is quite important, right? Because if you execute plan on some application, and for instance the plan execution fails, so it would be nice to kind of figure out what was the reason for failure. So because this gives us some important information about where the problem might be. So whether the plan was not executed because, for instance, a robot ran out of battery, for instance, right? So, and this is something that we simply would like to explain in some formal way. Also, when we have models that we don't really need training like we do for LLMs. Of course, that load is still somehow transferred to people who write these models, so that we don't have any automated system to do that, but still people need to come with models. But one thing is that when people develop models, so they also have some knowledge, how it works, and therefore, for instance, if there are some changes of requirements or some application environment, so the models can be more easily maintained. So that just to say that we need models not only to perform automated reasoning like for plant generation, but also for explainability, verification, validation, and so on. So to give you some insights about what is actually the knowledge engineering process for planning and scheduling. So we have that domain in the real world. For instance, we might have a game that we would like to somehow describe in a symbolic model, like for instance in PDDL. So what are the steps that we should do? One is to somehow try to understand the knowledge behind the domain, to somehow conceptualize that knowledge, to kind of refine the requirement of what we are going to model, what is basically our goal for that application, what we would like to do. So that in case of game testing, we might have a strategy game, and we might need to figure out that we are going to test whether we can build buildings, whether we can train units, and whether, for instance, the units can move and so on. So this might be that knowledge acquisition process, which bring us to some concepts that we would like to model. But this is just a part which is kind of semi-formal. So the next step is to actually develop the model, so that we need to take the knowledge that we conceptualize, and we need to develop model, for instance the model in PDDL, so that it can be useful for planning engines. Now, the first step is that we need to verify whether the models are correctly implemented, so that we actually model what we would like to model, right? So that we might have, for instance, some testing problems where we might try to generate plans, and we might try to look at some cases that, for instance, if the plan is not generated, so that there might be some extra precondition or something missing effects or so on, right? Therefore, this is another step, and also in software engineering, you need to make sure that what you are deploying somewhere behaves correctly, or at least with a high amount of confidence. And the last point is that sometimes there are some changes of the requirements, so that we might need to model more aspects of the game, so or there is some more significant change in game mechanics because developer decided that, I don't know, units can be teleporting or some units, and we need to add a support for that to our model, right? Or sometimes also there might be some new technique, new planning agents, so that we might want to somehow optimize the model in some way, so that we are able, for instance, to generate better quality plans or just generate plans more quickly. And now, what is the role of LLMs in this process? So how they can or cannot support that CAPS process? And for the acquisition, there is some potential, because if you have, let's say, a lot of knowledge in some not how to say, not ordered form, or somehow messy, they still might be able to refine some important aspects. So they might actually help to somehow identify important concepts that we need to consider so in our modeling. But of course, there are some limitations, and especially if the problem that we are modeling is very specific or something which has not been yet done, right? Because especially if it comes with new games, then if the game is just starting to be developed and it is not something which is similar to some other games, then we don't really have that knowledge out there, and LLMs are unlikely to help us, right? So that, yes, we can use that because we are able to, refine some sort of knowledge, but there are some limitation that, if we don't really have, a good knowledge which is out there, about the application area, so that the LLMs are unlikely to be helpful. Now, the second aspect is about when we actually conceptualize the knowledge, then, we would like to use LLMs to actually create a model. And one thing is, well, PDDL is not that well supported by LLMs like, other programming language like Python or C, because there are not yet that many examples there. And the thing is that we can still kind of use the same style of development like in vibe coding, but it still relies on human expertise. Because I mean, often there might be, extra preconditions, there might be missing effects, and one needs to figure out, how to, fix the model properly. Of course, if you have some like common type of actions like moving, so that LLMs are really able to provide, the PDDL formulation. But if there is something which is more complicated, so that LLMs are less likely to help. And maybe here also I quote some discussion that we have with colleagues some time ago, that often LLMs are like students who are not well prepared for the exam. They have some intuition how the answer should look like, but they don't have full knowledge in the area, and LLMs are somehow working in the similar way. But there are still ways how we can use that, because sometimes LLMs might propose some alternative modelings, or they can be used as a support tool, so that we might simply prompt them and try to figure out, for instance, if we have well conceptualized the formulation of the knowledge, whether our model actually matches the one which is described in the document. So that still LLMs might help, but it is in the same sense like vibe coding, at least I would say. But what about verification and validation? So of course the problem is that even for LLM validation itself, so it is an open challenge, and this is something where we believe that LLMs can't really help that much. But I mean, still, there might be some way how they can actually support it, that you might ask some queries and somehow try to, so as I said before, look whether, the knowledge in some document matches the model itself, right? So that there might be some ways. Also, it might be possible to actually, there is some support for model for model reconciliation, and yeah, and so on. Now, about the maintenance. Actually, with LLMs, we might sometimes get some help in debugging the models. We might, find out why, for instance, we were not able to generate plan because there might be something which is missing, and LLMs might be able, to figure it out. And also, if, for instance, we might be able, to somehow, support legal recognition, or some changes to the model, like including honeypots in cybersecurity domains and so on. Also, which is not that related, that LLMs might even help in designing heuristics. And so to conclude, what we say that in CAPS, that simply there is some role of LLMs, that they might help, but of course, especially in safety-related domain, we still rely on symbolic models, because this is something, as I said at the beginning, useful to figure out whether we actually model the application correctly, and whether plans are meeting desired criteria. And here, what we should say that LLMs actually can be helpful in the knowledge engineering process because, as I said, we might get some interesting feedback from LLMs where we are trying to acquire knowledge or do some maintenance. And yeah, that's it from me. Thank you for your attention.
Thank you, Lukas. Thank you, Lukas. We have time for questions.
Are you using LLMs even experimentally to design the PDDL in your company for games?
That's a good question. I mean, we did some experiments, but especially for these scenarios that LLMs are not that helpful because the game is somehow unobserved knowledge, and sometimes we can't even use that because if the knowledge is about the game is passed to some LLMs, so that gaming companies are not happy about that. But there was a workshop paper and poster about how to use LLMs to specify goals, because there where user needs to specify the testing goal in natural language. So and then the LLMs should provide PDDL formulation.
Any more questions? Okay, I have one. So it looks like you use the LLM essentially to prompt it once and then expect to get the answer back. Did you also look into like some newer agentic approaches where you have the reviewer included, for example, and where you can have a dialogue with the system?
I mean, I personally didn't do much with LLM, so it is mostly on the Mauro side. But I mean, the idea is, if you use just a single prompt, that usually you don't get, meaningful answer. So that of course you need to reprompt that and to look at, aspects of the model and think, okay, but when you are moving, maybe, you should, delete the location of origin in the effects and stuff like that. So that, yeah, to some extent, one might be able, with prompts to kind of fix the model. But I mean, for me personally, it is more work to do with LLMs than to do this by hand.
Are there more questions?
Thank you. So this was about LLMs. Do you have some ideas also about VLMs because of their understanding capabilities for example, grounding PDDL atoms into real-world perceptions or something like this?
I mean, yeah, I saw some works around the area, so that, I didn't do anything myself in that. But I mean, yes, the idea is that, for instance, observing some state, by some picture, so can give you, for instance, initial state of the goal, or sometimes you might be even able to do some maybe sequence of actions. So I don't know how we can use that to actually create the domain model itself, because for these I think we might extract some information about how the state might change, or maybe LLMs can do some background information that if they see some images of blocks world, then they can just just give the Broxford domain model because it is well known. But I mean, I don't know that much because I did not really experiment with these LVLMs that much.
We have time for one more question. Okay, I have another one. So when you set up the system to generate the PDDL, and you yesterday showed, or the day before yesterday showed this goal generation, I was wondering, I mean, sometimes you may have just question for the model, what can I actually represent, right? So to actually introspect an existing model, when you also spoke about maintenance, for example, where you actually want to see what the model can do and then maybe how you can extend it. Did you look into this by any chance?
I mean, for maintenance, that sometimes, it depends, of course, what sort of changes they are, that, it might be possible to somehow ask the model to say, okay, if we need to add some functionality, then, LLMs with the existing model, can give us some answer. But I mean, as I said, so in my experience, it is still somehow, tricky, at least for me, to use that for knowledge engineering. So that's, I still do that this old-fashioned style of hand coding, and yeah. But I guess that there is some potential, and especially for some aspects like goals, because this is something that you need usually for one model. You might need hundreds or thousands of goals, and if you don't have users that who are, of the system who are capable to model it in PDDL, so that LLM can help, because you also give some good restrictions of how the goal should look like, because you already have the model, so the LLMs can connect the dots more easily than when they just need to refine existing or the whole model. So.
Okay, let's thank the speaker again.
Thank you.